A very good morning to everyone and wishing you a very happy Diwali. So before Diwali I think we didn't met actually, right? So the last time we met I think was in the last week of October, most probably. I think so. So how was your mid-semester examination, guys? The paper was little tough. Intentionally the paper was being designed quite tough. 4 to 5 questions were designed quite tough. Other than that, how was the paper? Yes, guys. Other than that, how was the paper? I hope you all are out of the vacation mood now. Okay, Parthiv is saying great. So I think he is scoring 30 on 30 this time. Yes or no, Parthiv? Yes, students, just give me response. Respond to my questions. Okay. What about others? How was the paper? I think result is not declared yet, but I'm just talking about the paper. Okay, Lisa is saying good. Others? Okay. So I think that before Diwali we have revised unit number 1, 2, 3 and 4. Am I right? Before Diwali we have revised unit number 1, 2, 3 and 4. Introduction, relational algebra, ER diagram and normalization most probably. So what next to be revised? As per your choice we can start. I was thinking of transaction chapter, but still if you have any other choice you can just tell. Okay, Parthiv is saying transaction. Yes, students. Any other things to be revised? Most probably we are having today's 2 lectures and next week's 2 lectures. So we are having in total 4 lectures. So what all topics you want to revise, you can just give me a concern regarding that. Okay, we can go with transaction. That's great. Fine. No issues. We'll start with transaction then. No issues. Okay, so before I start with the transaction chapter and its revision, what do you mean by transaction? Give me the answer. Be quick. What do you mean by a transaction? Let's discuss. What do you mean by transaction? Okay, anything under execution is transaction. A set of operations being executed in a proper sequence so that all the operations are executed successfully and the complete task is done 100%. That is what we call it as transaction, right? So let's see now each of the topics in brief, right? So let's have a quick revision in today's 2 lectures for transaction chapter, right? So let's see. Anything under execution can be known as transaction. Transaction is a sequence of operations being performed as a single logical unit of work that contains one or more than one SQL statements. That is what I said. We are going to execute the different statements, the different operations of DBMS in a particular sequence, and all these operations will be considered as one single task, and that one single task is known as transaction. As you can see in the example, we are having about 6 different operations and all the 6 operations are considered as one single task known as transaction. Right, so this is what all about transaction is. Then we have acid properties. So what do you mean by acid? Be quick to answer. What do you mean by acid? ACID. What do you mean by acid? Be quick to answer. Yes, students. What do you mean by acid? Atomicity, consistency, integrity, and durability. Yes. So, what is atomicity? Atomicity mainly says that if your transaction is getting worked, right, then either it will work 100 percentage or it will not work at all, right? That is 0 percentage. So, transaction is done 100 percentage or transaction is done 0 percentage. That is what atomicity means. Then comes consistency. Consistency means it is saying that you make any changes to the database, you change any values of any attributes, but ultimately your database should be in a consistent state. That is what consistency means. That means you will get a consistent data, you will get a reliable data. That is what consistency says. Then comes isolation. Isolation means no other transaction can intermediate or no two transactions can interfere in each other's task. They will be not knowing any of their tasks, that what each transaction is performing. Right. So what each transaction is going to do, or what each transaction is going to make any changes in the database, each transaction will be knowing its own task. No other transaction can interfere in their work. That is what isolation, that means separate work. Each transaction works separately. Then we have durability. Durability means it is not like that if we make any changes to the database, that changes will stay there for only for few amount of time. No, it is not like that. It will remain as it is till n number of years, until and unless some other user changes that data. So we cannot change the data, or the data cannot be changed automatically until and unless some user is forcefully or manually changing that data, right? So the data remains for n number of times or n number of years without having any types of problems. That is what we call it as durability, right? So this is all about acid property, atomicity, consistency, isolation, and durability. The next is transition state diagram. So can you tell me what are the different components of state diagram, or what are different states of transaction? Anyone who would like to add here? Different states of transaction. What are the different states of transaction? Anyone? Okay, active, partially committed, committed, failed, and aborted. So what do you mean by active? Yes, what do you mean by active state? means we are saying that our transaction has started its work. The operations have get started working. That is what we call it as active state. Then we call it as partially commit, or we can partially committed. That means our transaction has reached to the last stage. It is about to complete or end all its operations. That is what we call it as partial committed. If our transaction is in active, then there are two possibilities. Either it will go partial committed or it will go failed. So if it is failed, that means there are some errors and transaction cannot work ahead, cannot move ahead. So we need to go back, we need to roll back, right? So if it is partially committed, then also our transaction may get failed because we may get some types of errors at the last stage of our transaction or operations, right? So if it is partially committed, we may get failed. If it is getting failed, we need to abort our transaction. Abort means we completely revert back all the changes made by the transaction and go back to the initial position, that is before the active state. And if it is partially committed, if it is failing, we are getting aborted. If it is not getting failed, then it will commit. Commit means all the operations of the transactions have got successfully completed, and now we are ready to say that yes, we are done with all the changes. That means commit. All the things are done successfully. That is what we call it as commit. Right? So these are the 5 states of our particular transaction: active, partial committed, failed, committed, and abort. Is there any doubt, anyone in this? Anyone is having any doubt in this? No one? That's fine then, if there is no doubt. Let's move ahead. The second one, or the next topic in our transaction, is the transaction operations. We already know that there are mainly 2 types of operations in transaction. One is read. Read means you can only see or access the data. And second one is write. Write means you are only writing, you are able to read, you are able to access, you are able to insert, you are able to update, you are able to delete. All the types of operations of SQL you can perform in write. But in read, you can only access the data. You can only access the data. Right? So clear with the operations? So based on the operations, we have scheduling. Now what do you mean by scheduling? Anyone? Anyone? What do you mean by scheduling? What do you mean by scheduling? Anyone who would like to add it here? What do you mean by scheduling? Anyone who would like to add? What do you mean by scheduling? Okay, scheduling means you are actually ordering, or making a sequence of all the operations of a transaction. That is what scheduling means. So what we are actually making sure that all the operations of a schedule or the transaction will be executed in a proper sequence and one by one, and that is why we call it as a serialized schedule or serial schedule, right? So we are making sure that our transactions are going to execute one by one in a sequence, and they will maintain the serialization of each and every operations, right? So that is what the schedule or serialized schedule mean. So this is what the clear example of this. You can see transaction 1 will get execute first, and then transaction 2 will get execute. Once the transaction T1 gives the commit command, T2 will start, otherwise it will not start. If the transaction is not giving commit command, then the other transaction cannot start. Right? So this is what serialized schedule means. And second one is interleaved schedule. What is interleaved schedule? In interleaved schedule, the transactions do not wait for the other transaction to give the commit command. They will start their work before the commit command has been executed. Right? So you can clearly see in this particular example, T1 is reading a data of A. It is making some changes on A, and before that T1 has given a commit command, already T2 has got started and it is already performing its operations, and later on then T1 is giving the commit command, and then later on T2 is giving the commit command. So this is what a clear example of, we can say, interleaved schedule is, where each transaction starts before the other transaction has given a commit command. So this is what serial schedule means. One transaction starts its execution only after the first transaction has given the commit command. But in the interleaved schedule, we are saying that one transaction starts its execution before the commit command has been executed. So this is what serialized and interleaved schedule means. Any doubts? Anyone so far? Anyone? Any doubts so far till here?
Yes, sir.
Anyone? Any doubts so far in this? Alright, then let's move on and move on. The next is the concept of serializability. Now what is serializability? We call that a transaction is serialized, or it is having a property of serializability if it manages two different transactions at the same time and also make them serialized. That means they provide the sequence. Both the transactions will execute at the same time, and they will also maintain the sequence of their operations. That is what serializability means. And we are having two types of serializability. One is conflict serializability, and second one is view serializability. Now what is conflict serializability? Conflict serializability means, let us say the two transactions are conflicting each other, so we need to manage these transactions. Right? Now when we can say the transactions are getting conflicted? Anyone? When can we say the transactions are having conflicts? When can we say our transactions are having conflicts? When can we say our transactions are having conflicts? When can we say our transactions are having conflicts? Anyone would like to add the answer for this? When can we say our transactions are having conflicts? Very simple question. When can we say the transactions are having conflicts? Yes, exactly. When one transaction is reading and the other transaction wants to write the same data item, at the same time we can say it is a conflict. That means I am reading data item A, and at the same time some other person also wants to update something on data item A, then there will be a conflict. So the conflicting operations are when at least one transaction is writing and the other transaction is reading. At that time there will be a conflict. You can see this example very clearly. You can see if both the transactions are accessing the different data items at the same time and they are having two different operations, then also we can say it will not be conflict because they are working on different data items. So now we are talking about conflicting transactions and we want to resolve that conflicts. So give me the answer for this, that where there is a conflict and how can we make our transactions without any conflicts. Can you give me the answer for this? How to make these two transactions non-conflicting transactions? How to make these two transactions non-conflicting transactions? Anyone would like to add here? You can clearly see that we already have T2 first stage and T1 second stage as a conflicting. So what we will do, we will just swap these two operations and we will make sure that there is no conflict among the transactions. If they are reading two different data items at the same time, there is no conflict. So we have solved that particular problem. So this is all about the conflict serializability. That is, we are trying to remove the conflicts among the transactions and their operations by swapping some of the operations among the transactions. That is what conflict serializability means. The second one is view serializability. Now what is view serializability? It is saying that assume that we are having same number of transactions, or we can say same number of schedules. Each schedule are having same number of transactions and they follow the following three conditions. The first condition is initial read, second condition is updated read, and the third condition is final write. So if each of the three conditions are getting satisfied by each of the transactions of each schedule, then we can say that our schedules and our transactions are view serialized, or we are saying that a property of view serializability is getting achieved. So this is what view serializability means. We are going to see now what each of these particular conditions wants to say. So first one is initial read. Now what is initial read? If in schedule R1 transaction T1 reads the date value of T, then in schedule R2 also transaction T1 should read the value of data item T. So you can clearly see in the example, in schedule R1 T1 is reading, T2 is writing. In R2 T1 is writing, T2 is reading. And in R3 T1 is reading and T2 is also reading. So what is the condition? If in R1 if T1 is reading a data item, then in all the other schedules, that is R2 and R3, T1 should read the data. But we can clearly see here that in R2 T1 is not reading the data, but the data is being read by T2. So T1 and T2 cannot be said as view serialized. But in T3 again, T1 is reading the data item T. So we can say that schedule R1 and R3 are view serialized, because in both the schedules T1 is reading the data item T. So this is what initial read means. Second one is updated read. Now what is updated read? If in schedule R1 T1 executes read operation that was updated by T2 transaction, then in schedule R2 also T1 should read a data item that was updated by transaction T2. So this is what the condition of updated read means. So it clearly says that if a transaction is reading a data item that was updated by some other transaction, then the same thing should be reflected in the second schedule or third schedule. Now you can see the example. In R1 T1 has written data item A. In T2 has again updated data item A, and T3 is reading the data item A that was lastly updated by transaction T2. So now R1 is having this type of scenario where T3 is reading a data item A that was updated by transaction T2. So same scenario should be there in R2, that is schedule 2. Now let's see. In R2 we are first having T2 writing some data item A. Then we have T1 which is again updating some data item A. And then we have T3 that is reading a data item A. But here T3 is reading a data item A that was updated by T1, not T2, because in schedule R1 we are saying that T3 is reading the data item that was updated by T2, but in R2 we are reading data item, T3 is reading data item that was updated by T1. So this is not satisfying the condition of updated read. So let's take the second example. Here you can see T2 is reading data item A, then T1 is writing data item A, then T2 is again writing data item A, and then T3 is reading data item A. So here we can say that T3 is reading a data item A that was updated by T2 lastly. And in the schedule 2, let's see, T2 is reading data item A, it is writing data item A, then we have T3 reading data item A, and then we have T1 writing data item A. So again here T3 is reading a data item A that was updated by T2. So in the both the schedules we can clearly see that T3 is reading a data item updated by T2. So here we can say updated read condition is getting satisfied. Right? So this is what updated read means, and the last one is final write. Now what does final write says? Final write clearly says that transaction T1 performs final write operation on some data item in schedule R1, then in schedule R2 also T1 should write the data item at last. That means the write operation should be executed at the last by the same transaction in all the schedules. Again I am repeating, the write operation should be executed at last in both the transactions, right, in both the schedules by the same transaction. So you can clearly see here R1 T1 has written, T2 has read, and T3 has written at last. Similarly in R2 T2 has read, then T1 has written, and then at last T3 has written. So in both the schedules we can clearly see that T3 is writing the final operations, right? So we can say it is satisfying the condition of final write. So when final write, updated read and initial read, all the three conditions are getting satisfied for all the schedules in a transaction, then we can say it is achieving the property of view serializability. It is achieving the property of view serializability. So this is all about conflict serializability and view serializability. Is there any doubts so far? Anyone? Then please raise it. Then we can move on to the next. If you have any doubts, just raise it. Else we will move on to the next. Anyone, any doubts so far in transaction that we have revised? Then we can start with two-phase commit protocol. You can refer to the PPT that I already uploaded in your e-content, and you can refer to all the topics that we have covered so far till now. And if you have any doubts, just tell me. Yes, students. Anyone? Any doubts? Till now? Yes. Anyone? Any doubts till now? Yes or no? Yes, students. Awaiting your response in the chats. Anyone, any doubts so far? Okay, then let's move ahead and let's discuss what is two-phase commit protocol is. So anyone who would like to give any highlights on two-phase commit protocol? Anyone who would like to add something on two-phase commit protocol? What do you mean by two-phase commit protocol? What is the use of two-phase commit protocol? Anyone would like to add here? The two-phase commit protocol. The two-phase commit protocol mainly ensures that our transaction and all its operations are going to get executed successfully, or if there is some error, then all the operations will be reverted back to its initial position. Now what is two-phase commit protocol here? It clearly says that there will be one controlling node who will give some messages or some orders to all the participating nodes. Now here nodes means we can say schedules or the transactions. So each schedule will be having some different transactions, or each transactions will be having different set of operations, and one schedule or one transaction will act as a controlling node, and all other will be known as participants, slaves, or cohorts. And it involves mainly two phases: prepare phase and commit or abort phase. Now how it works actually, let's see. So let us say in the middle we have a controlling node, and each of them are going to obey the orders being sent by the controlling node. So let us say when the transaction is about to complete, the controlling node will give a request to prepare message. Now what does this message has? The message clearly states that are you all ready to commit your transactions, commit your schedules? That means, are you all ready to complete all the operations of the given schedules or transactions? If all are ready, then each of them will say, yes, we are prepared. That means, yes, we are ready. They will say that, yes, we are ready to commit all our operations, all our transactions. We don't have any issues. So if this controlling node gets this particular message from all the participants that yes, we are ready, then this controlling node will send a global commit command. A global commit command means it will say that each of the participant will now commit their transactions. Each of their participants will commit their transactions, right? So when all the transactions commit their work, right, they will send back the acknowledgement message, that is done message, to the controlling node. That means, yes, they will say that we have committed our transactions and all the changes are being reflected to the database. So this is what the first part of two-phase commit protocol is, where all of them are ready to commit and they have committed their transactions and they have made the changes permanent in the database. Now let's say the second part. The second part says that in the initial stage, again, the controlling node sends the message to each participant for either they are ready to commit or not. So it will say that are you ready to commit your transaction or not. Now if assume that one of the transactions says that I am not ready to commit. One of the transactions says that I am not ready to commit. So at this particular moment, what happens? A controlling node will wait for some time and then again will send the request to prepare. That means again it will ask each participant that are you ready to commit. Now again if some participant says that I am not ready to commit, then at that particular moment what the controlling node will do, it will ask each of the participating node that all of you abort your transactions. All of the participants will be forcefully asked to abort their transactions. That means forcefully fail their transaction and abort it. That means roll back to your initial position. Revert back all the changes that are being made to the database. And once all the participants get abort message, all of them will abort their transaction. They will revert back all the changes done to the database and then send done message to the controlling node. That means, yes, we have rolled back all the transactions, we have reverted back all the updates made to the database, and we are now at the initial position and the complete transaction will start again. So these are the two scenarios in two-phase commit protocol. Once all are ready and commit is done, other part, one of them is not ready and all the transactions are getting aborted. So this is what two-phase commit protocol means. Any doubts in two-phase commit protocol? Anyone? Anyone? Any doubts in two-phase commit protocol? Yes or no? Any doubts in two-phase commit protocol? Anyone? Any doubts in two-phase commit protocol? Yes or no? No doubts? Sure? Everyone? Clear till now? Okay, then let's move on to the next topic then. The next topic is database recovery. So at a times we may face that yes, we are having some issues and the database has got failed, the transaction has got failed, and database might have gone to the inconsistent state, right? So now how to recover the database? So we are talking about database recovery. So in how many ways a database can fail? First of all, or transactions can fail, disk failure, database software has crashed, there is some OS failure, or there is some power failure, right? So all these problems may lead to the database inconsistency. So we need to have some mechanism so that we can recover our database from the point of failure or from the first phase, wherever it is possible or whichever is possible, right? So for database recovery we are having different methods. The first method is log based recovery. Now what is log based recovery? At the regular interval the transactions are going to create different types of logs, and now what will be the logs? What will log look like? The log will have the start time of transaction, the transaction ID, then which table actually it is working on, or on which database that transaction is working, what type of operation that transaction contains, what is the old value of that particular database, and if there is some particular changes in the database by that transaction, then what will be the expected new value of the database, and what is the status of the transaction, either it is committed or it is aborted. That means at regular interval, whenever one of the stages of the transactions are getting successfully completed, the logs will be generated automatically and it will say that yes, this stage has been done successfully, that means committed. And likewise it is going to create each and every logs. Now if we say after third stage we have a particular failure, so we can try to recover our database till the third stage. That means we can get the log of the third stage and we can come to know that what type of changes have been made to the database in the third stage, and we can start our transaction again after recovery from the third stage. So this is what we call it as log based recovery. Now we are having two types of log based recoveries. The first one is immediate database modifications. Now in this immediate database modifications, what it does in the log based recovery, whatever changes being done to the database, right, whatever changes are being done to the database, all the changes are reflected to the database immediately the operation is executed, immediately after the operation has been executed. It will not wait for the commit command. So let us say I am having 5 operations, and after all the operations are updating some data values, and in the log based recovery also the database is getting updated immediately before the commit command. Now after the fourth operation there was a failure. So what I have to do? I have to revert back all the 4 changes in the database, and also I need to go back to the first position, right? So this is what the problem with the immediate database modification would be, that you need to revert back all the changes made to the database because commit command was not executed. And second one is deferred database modification. Now deferred database modification means all the changes to the database will be given or will be made only after the commit command is executed by the transaction. So what will be done in this case? Yes, the transaction operations will get execute, but it will not make any changes to the database. So if there is some failure, we do not have to revert back all the changes. Only we have to restart our operations. In immediate, we need to revert back all the changes made to the database, as well as we need to restart our operations. So this is what log based recovery means. We are having 2 types of recoveries: immediate and deferred database modifications. The second type of recovery is checkpoints. Now what is checkpoints? Checkpoints means at a regular interval we are going to create some type of checkpoints, so that we'll come to know that whether the transaction has started, whether the transaction has already committed, whether the transaction has got failed. So something like that we will come to know from the checkpoints. So you can see this image. We have created one TC checkpoint and we have one TF failure point. So we are having 4 different transactions. We can clearly see that transaction T1 started before the checkpoint and has already completed before the checkpoint, right? Then T2 has started before the checkpoint and it has committed after the checkpoint has passed, right? And you can clearly see that T3 has started after the checkpoint and it has already committed after the checkpoint and before the failure. And we can clearly see here that T4 has started after the checkpoint and before the failure, and even after the failure T4 was going on. T4 was continuing its execution of operations. So now what to do, or what we can assume from this, or what we can do from this scenario? So we can say that we do not have to touch T1 transaction because it has already completed all its tasks before the checkpoint. So we are not considering T1 right now. Then we can see here T2 started before checkpoint and has committed after checkpoint. So we need to restart T2. Similarly, T3 started after checkpoint and committed after checkpoint. So again we need to restart the T3 because we don't know what is the state of T3 during the failure state. So T2 and T3 are going to get restart. T4 is not going to get considered at all, and whatever changes the T4 has made in the database will be completely reverted back, and we are also not going to restart T4 because it has continued its operation after the failure point. So T4 will be not considered in restart as well as in database changes, right? Only T2 and T3 will be restarted. So this is all about our checkpoints. This is all about checkpoints, that from the checkpoints we can come to know which transactions can be reverted back, which transactions will be considered for restart, and which transaction will be ignored completely, right? So we can say T1 will not be touched at all because we don't want to see what changes T1 has made. T2 and T3 will be touched and will be asked to restart because they committed their task after the checkpoint was passed, and T4 will be completely ignored because it has failed and it was still continuing its task even if after the failure. So this is all about the checkpoints, right? So far any doubts, anyone? So this is the two types of database recovery, log based recovery and checkpoints.